It turns out that every local maximum or minimum point is always going to occur at a critical point. Thus, if we found all the critical points of the graph of a function, we found a number of possible maximum or minimum points. The question now is how to tell if a critical point is a maximum, a minimum, or neither. The first method we're going to use to test whether a critical point is a maximum or minimum is what's called the first derivative test. It's called the first derivative test because we're going to use the first derivative of the function in question to determine whether the critical point is a maximum or if it's a minimum. The first derivative test says that if the function switches from increasing to decreasing, basically if it goes up, then it comes back down again, then the point in question is a local maximum. It says that if it switches from decreasing to increasing, then the point in question has got to be a local minimum. Thus, to perform the first derivative test, what we must do is locate all the intervals of increase and decrease. Then we can figure out where the local maxima and the local minima are by looking at those intervals. So now I'm going to do an example where I use the first derivative test to locate all the local maximum and minimum points of a function. So here in the first example, the function is f of x equals x to the fifth minus 15x cubed. So the first step is I need to find the derivative so I can find the critical points. So I get 5x to the fourth minus 45x squared. Now I'm going to factor this to make it easier to find those critical points. So I'm going to have 5x squared. I'm going to be left with x squared minus 9. X squared minus 9 will factor as x minus 3 times x plus 3. So if I want to ask when is this first derivative 0, well it's 0 either when 5x squared is 0, which happens when x is 0, when x minus 3 is 0, which happens when x is 3, or when x plus 3 is 0, which happens when x is negative 3. Great. The other thing to mention is this first derivative is never undefined. Its domain is all real numbers. Now I've got these critical numbers, and I'm going to use them to divide up the x-axis into intervals. So I'm going to put the negative 3 here, the 0 here, and the 3 here. So I'm going to have an interval from negative infinity to negative 3, an interval from negative 3 to 0, an interval from 0 to 3, an interval from 3 to infinity. We're going to try to figure out whether it's increasing or decreasing in each of these intervals, and that will tell us which of these critical numbers are local maxima and which are local minima. So to pick a test point in this interval, we could pick negative 4. Test point in this interval could be negative 1. Test point in this interval could be 1. This one could be 4. So I plug in 4 into the derivative. I'm going to have 5. Negative 4 squared is going to be positive. Negative 4 minus 3 is going to be negative. Negative 4 plus 3 is going to be negative. This gives me a positive result. Plug in negative 1. 5 negative 1 squared is positive. Negative 1 minus 3 is negative. Negative 1 plus 3 is positive. This gives a negative result. Plug in 1. 5 times 1 squared is positive. 1 minus 3 is negative. 1 plus 3 is positive. This gives a negative result. And plug in 4. You get 5 times 4 squared, which is positive. 4 minus 3 is positive. 4 plus 3 is positive. This all gives a positive result. So here it's increasing. Here it's decreasing, here it's decreasing, and here it's increasing. Which means that it switches from increasing to decreasing here, this point is a maximum. Since it switches from decreasing to increasing here, this point is a minimum. This point is neither a maximum nor a minimum because it goes from decreasing to decreasing. So if I want to find my local max x coordinate is going to be negative 3. If I plug in negative 3 into the original function, I'm going to get 162. And if I want to find my local minimum, I'm going to plug in 3 into that original function. And I'm going to get 3 for my x-coordinate, and my y-coordinate there is going to be negative 162. So this is my local maximum, this is my local minimum.